Okay, we are ready to start. Good morning, everyone. We first need to confirm if you are able to see the screen. Anyone?
Yes, sir.
Yes, sir.
Thank you. Thank you very much. Okay, so we will start where we have left off. In fact, there is one example on the topic that I wanted to cover is so last time we talked about the probability of the union of events. Probability of union of events. And the simplest example for that was probability of A union B. We don't know anything about whether A and B are mutually exclusive or not. Don't know anything about them. So you saw that, if A and B are mutually exclusive, then the axioms of probability tell us that this would simply be equal to probability of A plus probability of B, if A and B are mutually exclusive. However, there can be a case when A and B are not mutually exclusive. So this probability of A and probability of B, it's basically double counting. It's double counting this common area between A and B. So we have to subtract that off, A and B together. So this is intersection of A and B. Uski probability, we have to subtract that from this probability of A plus probability of B. Okay. And then we generalize this. We said that we have this generalization. So what we have here is union I going 1 to n AI would be equal to summation I is equal to 1 to n probability of AI. Okay. This would have been our answer if all the AIs were mutually exclusive. Agar sare mutually exclusive hote, so this would have been our answer from the axioms of probability, which says that probability of the union of mutually exclusive events is equal to the sum of individual probabilities. But we don't know much about AIs, whether they are mutually exclusive or not. So the generic expression would be, since you have added all these probability, you would be overcounting or double counting or triple counting some of the areas. You will have to subtract those. So probability of single guys, probability of AI summation over all n. We have to consider that, and then we have to subtract all the pairs. We have to subtract all the pairs minus summation for all I1 less than equal to I2 less than I2 less than, just for I2, because we are going to subtract all the pairs. AI1, AI2. Kitne pairs honge? How many pairs are there? Well, the number of pairs are going to be, you are choosing 2 AIs out of n AIs. So this would be n choose 2 terms, n choose 2 terms. So now when you do that, you will probably, you will subtract some of the areas more than needed, and then you have to add back those areas. So this would be summation I1 less than I2 less than I3, तीन का AI1, AI2, AI3. कितनी ऐसी terms होंगी? N choose 3 terms होंगी. N choose 3 terms. And minus 4 terms, 4 वाली terms plus 5 वाली terms all the way up to ये n तक कब चले जाएंगे. Okay. So there were a couple of examples that we did last time, as a example for probability of union of events. I'm going to do one more example, which would be the last example, and then we will switch the topic to conditional probability and independence. Okay. So the example here is pretty simple and interesting actually. This is called hat matching problem. And there's a lot of variations that you will see in the books, but hat matching problem in its simplest form, hat matching problem in its simplest form would be that, let's say you have n people, who have, each of them have a hat, and they throw their hat in a mix. There is a pool, and they just put all of their hats into this pool. सारे एक जगह पे mix कर देते हैं, एक box में डाल देते हैं. Now, after that, then they pick one each randomly. सारे या तो simultaneously उठा लेते हैं या एक एक करके उठा लेते हैं. Same thing. So n people throw their hats in a mix, and then pick one randomly. So this is the situation which is given to us. The question has not been asked yet. Okay. So the question is, what is the probability that no one picks their hat? No one picks their own hat. This would be very easy to answer if you have only two people. अगर सिर्फ दो लोग होंगे, तो this is very, very easy to answer. Very, very easy to answer. What would be the probability? If you have just two people, what would be the answer? So two people have answered in the chat window. There are 39 participants. 0.5, 0.5. So everyone is saying 1/2, 0.5. Yes, because if you have just two people, there are only two choices. One is both of them will get their own hat, or both of them will not get their own hat. Okay. So there is only two possibilities, and one out of those is this required possibility. So 1 out of 2. What is the probability that no one picks their own hat? That's the only possibility, that if one of them gets the other person's hat, the other person would automatically get the first person's hat. Okay. Now this gets slightly tricky when you have three people. And 4 and 5 and 6 and capital N people for a large number n, for a large value of n. What is that probability? So for two people, we saw that this probability is 0.5. This probability is 0.5. Anyone would want to make a guess? Anyone would want to make a guess that with large number of people, this probability that no one picks their own hat, is this going to be greater than 0.5 or smaller than 0.5? Answers in the chat window. Intuitively guess karna. Intuitively guess, no calculations. So everyone is saying smaller. Moise ne kaha कि greater. So we'll figure out कि smaller नहीं है. अगर voting पे जाएंगे तो smaller ही आएगा. Okay. But यहाँ पे हम voting से नहीं जा सकते, because we know that there is a right answer. बिल्कुल उसी तरह जैसे quiz के ऊपर भी हमने voting करवाई, but we got one right answer. Okay. So I don't know what that is the right answer or not, but we got one answer for the quiz at least. Okay. Now, so what is the probability that no one picks their own hat if you have larger number of people? It seems that if you have 1,000 people, what is the probability that no one will pick their own hat? कोई इसका जो है ना कोई range बताएं, कोई guess करें इस range के ऊपर. If you have 1,000 people, what is the probability no one will pick their own hat? Intuitively क्या लगता है? कुछ range बता दें between 0 and 0.5, between 0 and 0.1, whatever is your guess, just say it. Close to 0. Bilal is saying that close to 0, very, very small. Hamza says very, very small. So yeah, if you have 1,000 people, if I tell you 0.001, Walid says 0.001, Aun says at least 0.5. Well, we earlier decided कि ये 0.5 से तो छोटा होने वाला है. So if you have a million people, the chance that somebody will get their own head are going to be very, 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 very small. Very, very small. So Bilal says 0.5. So let's figure out. देखते हैं. Yeah. So this is a trick question. It's not easy to directly answer this for a large number of people, but we can use this probability of the union of events. ये जो हमने ऊपर ये probability of the union of events ये देखा, we can use this expression or this formula to our advantage. Okay, and we try to find out. Okay, the solution is, we try to first find out that at least one guy will get their own head. Okay? So easier to find out that at least one of the people will get their own head. Agar at least one person gets their own head, then ये वाला जो event है ये कभी true नहीं होगा. No one will pick their own head. So probability that no one picks their own head, this is a complement event. This is a complement event to 1 minus the probability that at least one person picks their So this is the same thing as saying कि आपने बहुत सारे लॉटरी के टिकट खरीदे and the probability that at least एक उसमें से एक लॉटरी जो है वो निकल आए, एक या दो या तीन या चार या पांच जितनी भी, at least एक भी अगर निकल आए, then this event will not be true कि you have not won any lottery, कोई लॉटरी भी नहीं जीते. So these two are complement events. So the probability that no one picks their own head is equal to 1 minus probability that at least one of the guys pick their own head. One of the persons will pick their own head. So it turns out that we have to find out this probability. Directly finding this is difficult. Finding this out is easier. Why? Because probability that at least one person picks their own head is the probability of union. कि या एक को आ जाए या दो को हेड मिल जाए या तीन को मिल जाए या चार को मिल जाए या पांच को मिल जाए. So ठीक है. So we define the event EI as the event that ith person gets their own head. ith person gets their own head. So this guy here, the probability of union, ये वाली जो probability है, this is the probability that union I is equal to 1 to n EI. This is the probability. और ये probability किस चीज के बराबर है? ये इस किसके बराबर है? ये हमने ऊपर लिख दिया इसका फॉर्मूला. So probability of union of AI, पहले एक को सम करें, फिर दो को सब्ट्रैक्ट करें, फिर तीन को सम, चार को माइनस, पांच को ऐड. सो करके देखते हैं. ठीक है. So this would be equal to I is equal to 1 to n probability EI minus summation I1 less than I2 probability of EI1 EI2. ये दो को सब्ट्रैक्ट करेंगे, तीन को ऐड करेंगे and so on and so forth. So first of all, when you have n people, capital N people, and you have n hats, what is the total number of elements in the sample space? What is the total number of elements in the sample space? You have n people and n hats. Everyone can pick any of the hats. How many total outcomes can you get? कितनी different outcomes? N power n. Bilal says n power n. N power n. N power small n. I don't know what is small n. N power n. सब कह रहे हैं n power n. देखें n power n इसलिए शायद कह रहे हैं कि इसलिए कह रहे हैं कि वो डाइस के केस में हमने देखा था कि 6 faces and then another 6 faces, तो you know 2 dice rolled together would be 36. But in this case think about it कि अगर एक हैट एक बंदे के पास आ गया है, वो अब दूसरे के पास नहीं जा सकता वो वाला हैट. So for the first person you have n different possibilities. For the second person you don't have n different possibilities. For the second person you have n minus 1 possibility. So the number of elements in omega is, पहले first person के लिए n possibilities हैं, can pick any of the hats. Second person can pick n minus 1 hats. आखिरी जो बंदा रह जाएगा उसके पास एक ही हैट बचा है. अब वो नहीं, उसके पास वो और कोई चॉइस नहीं है. So this is actually n factorial. This is n factorial. This is n factorial. Okay. So let me ask you this question. What is the probability of E1, E2, E3, up to En? What is this event? पहले तो ये बताएं कि what is this event? Answers in the chat window. What is this event? E1 and E2 and E3 and E4 up to En. What is this event? So EI is the event that ith person gets their own head. So this is the event that everyone will get their own head. Everyone will get their own head. What is the probability of this event? What is the probability of this event? How many ways this event can occur? How many ways this event can occur? There is only one way this event can occur. There is only one way this event can occur. And how many points in the sample space? It's capital N factorial. So this is this probability. लेकिन हमारा इसमें इंटरेस्ट नहीं है. ये तो हमने आपसे वैसे ही पूछा. हमारा इंटरेस्ट किस चीज में? हमारा इंटरेस्ट प्रोबेबिलिटी ऑफ E1 में, प्रोबेबिलिटी ऑफ E1 E2 में, E1 E2 E3 में, एंड सो ऑन. आखिरी वाली जो टर्म होगी वो ये वाली टर्म होगी जो हमने पहले से कैलकुलेट करके रखी है, नाउ
सर आप ये एक्सप्लेन कर सकते हैं कि नंबर ऑफ एलिमेंट्स इन सैंपल स्पेस n फैक्टोरियल कैसे आया एक दफा फिर से?
वो हमने एक्सप्लेन किया कि द फर्स्ट पर्सन, लेट्स से कि पहला पर्सन है, उसने हैट पिक करनी है, उसके सामने n हैट पड़ी है. सो द फर्स्ट पर्सन हैज हाउ मेनी चॉइसेस? उसके पास कितनी चॉइसेस हैं? n चॉइसेस हैं. दूसरे पर्सन के पास अब n चॉइसेस नहीं रह गई क्योंकि वो पहला एक हैट तो वो पहला पर्सन ले गया है. बाकी कितने हैट बच गए हैं? अब तो आपके पास n-1 हैट बच गए हैं. सो ये बेसिक काउंटिंग प्रिंसिपल. So second person can get n-1 hat, and the third person can get n-2 hats, and fourth n-3, and so on and so forth. Last person has only one choice. जो एक हैट वहां पड़ा रह गया उसको वही उठाना पड़ेगा. पता नहीं किसका वो रह गया, शायद उसका अपना हो, शायद किसी और का हो, but the guy will have just one choice. So that's why it would be n factorial. Answers your question?
Yes sir, yes sir. Thank you.
Okay. So probability of everyone getting their own hat is 1 over n factorial. Now, what is this? I'm going to try to find the probability of EI1, EI2, ... up to EI small n. ये टोटल जो है ये स्मॉल n एलिमेंट्स. और ये मैं स्मॉल n इसलिए क्यों कह रहा हूँ? क्योंकि स्मॉल n के लिए अगर मैं फाइंड आउट कर लूँ तो स्मॉल n को अगर मैं 1 करूंगा तो इस वाले का आंसर आ जाएगा. स्मॉल n को 2 करूंगा तो इसका आंसर आ जाएगा. 3 करूंगा अगले का आंसर आ जाएगा. स्मॉल n को मैं चेंज करता जाऊंगा तो मुझे आंसर आ जाएगा. आई जस्ट नीड टू find this probability. If I find this probability, then I'm done. Okay, so this would be equal to number of elements in EI1, EI2, ... EIN divided by number of elements in the sample space, which is n factorial. Okay. Now the question is, how many elements in this event, how many elements in this event. So number of elements in EI1, EI2, dot, 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 EIN. That small n people, they get their own head, बाकियों का मुझे नहीं पता, बाकियों का हमें नहीं पता. They may get their own head, they may not get their own head, but these guys are getting their own heads. How many ways these guys will get their own head? There is only one way that all of these guys will get their own head. Get their own head. But what about the rest of the guys? The rest of the guys कितने रह गए हैं? Capital N minus n रह गए हैं. They may get their own head or they may get somebody else's head. How many ways? That would be n minus n factorial. बिल्कुल उसी तरह. ये कैसे n minus n factorial आया है? बिल्कुल उसी तरह से आया है जैसे हमने कहा था कि ये जो n people हैं, इनकी sample space में the number of sample points है that you have capital N hats and capital N people. You want to distribute capital N hats to capital N people. There are n factorial ways to do that. Now, small n को मैंने fix कर दिया उनके अपने hats के ऊपर. बाकी जितने बच गए capital N minus small n, जितने बच गए हमारे पास अब वही वाली प्रॉब्लम जो इस जगह पे थी वही आ गई है कि this number capital N minus small n, this number of people and this number of hats. Okay. How many ways you can arrange those? पहला पर्सन जो है वो जाके उन n minus n में से उठाएगा, दूसरा n minus n minus 1 में से उठाएगा, and so on and so forth. So you will get capital N minus n factorial in exactly the same way that you got n factorial. Okay. So the probability of this event, EI1, EI2, dot, 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 EIN is going to be equal to n minus n factorial divided by capital N factorial. Now, look at this expression. इस expression के अंदर ये probability of EI1, EI2 वाली terms हैं. How many terms EI1, EI2 वाली? And choose 2 terms. कितनी terms होंगी? 3 वाली and choose 3 terms. कितनी terms होंगी? 4 वाली and choose 4 terms. कितनी terms होंगी? Small n वाली and choose n terms. So summation I1 less than I2 less than dot 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 IN, probability of EI1, EI2 dot 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 EIN would be equal to how many such terms are there? There are capital N choose small n terms. Okay. Multiplied by the probability of one guy, which is n minus n factorial divided by n factorial. And this turns out to be factorial n minus n factorial multiplied by n minus n factorial divided by n factorial. Aha, so this is just 1 over n factorial. ये तो बड़ा सिंपल हो गया, ये तो बहुत सिंपल हो गया. ओके, सो इसका मतलब है कि ये जो हमने यहाँ टर्म्स देखी हैं, जो एक एक वाली टर्म है, वो 1 over 1 फैक्टोरियल है. जो 2 वाली टर्म है वो 1 over 2 फैक्टोरियल है. जो 3 वाली टर्म है, summation of all that वो 1 over 3 फैक्टोरियल है. So what we get here is कि probability of union I is equal to 1 to capital N E I would be equal to 1 minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus so on plus अब ये आखिरी वाली जो टर्म है आपके पास वो 1 over capital N factorial होगी. What would be the sign of that? उसका साइन जो है वो क्या होगा? प्लस होगा या माइनस होगा? प्लस होगा या माइनस होगा? आंसर इन द चैट विंडो. डिपेंड करता है कि कैपिटल एन जो है वो इवन है या ऑड है. डिपेंड करता है कैपिटल एन इवन है या ऑड है. अगर ऑड है, अगर ऑड है तो प्लस साइन होना चाहिए। देखें ये 3 के साथ 5 के साथ इसके साथ प्लस साइन है, अगर इवन है तो नेगेटिव साइन होना चाहिए। सो हाउ डू वी एक्सप्रेस दैट? इसको एक्सप्रेस करने का आसान सा तरीका है कि यहाँ पे हम वी जस्ट राइट -1 पावर n plus 1, ठीक है। सो whenever n is even तो -1 हो जाएगा, whenever it is odd तो ये साइन उसका प्लस है। Okay, so now this is not the probability that we wanted. This is the probability that at least one guy will get their own head. We wanted the probability that no one wanted their own head. So उसको 1 में से माइनस करना पड़ेगा। So required probability is equal to 1 minus probability of union I is equal to 1 to n ei, which is equal to 1 minus, अब देखें यहाँ पे इनके सबके साइंस फ्लिप हो जाएंगे, 1 plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus plus so on प्लस, और ये आखिरी वाले का भी साइन चेंज हो जाएगा। साइन चेंज में सिर्फ इसकी पावर को n कर दिया हमने, 1 over n factorial. Now recall के summation I is equal to 0 to infinity xi over I factorial. किसी को याद है ये क्या चीज है? ये फॉर्मूला किसी को याद है? What is this guy? Anyone remembers? ये this is the expansion for e power x, a Taylor expansion for e power x. तो e power x की ये expansion, so this has to be x power I over I. This is the expansion of e power x. Okay, so this implies that this is I is equal to 0 to infinity minus 1 power I over I factorial is equal to e to the power minus 1. But that is for infinite. So for very large n, for very large n, this probability goes to e to the minus 1, which is 0.368. So जो हमने पहले जो ऐसे लग रहा था कि ये बहुत क्लोज टू जीरो आ जाएगी, बहुत क्लोज टू जीरो नहीं आ रही है। This is 0.368. If you have a million people in the room, throw their heads, the chances that no one will get their own head is 0.368. This is a very surprising result, but you know, this is the true result. ये शायद हमारी इंट्यूशन एक्सपेक्टेशन को वायोलेट करता है, but you know what can we say? This is the result that we have. Now, so enough about counting and unions of events and intersection of events. I'm going to switch gear a little bit and move on to what we call conditional probability and independence. And these two concepts, although different, but they are interrelated with each other. So I'm going to talk about both of them simultaneously: conditional probability and independence. Yes.
तो हमने कर लिया कि for very large n हमारी probability 0.368 के करीब आती है, लेकिन अगर हमें ये बना 100 n है, n100 है या n50 है, तो फिर हम क्या आंसर होगा, कैसे फाइंड करेंगे?
सो ऐसे फाइंड करेंगे, ये जो मैंने सर्कल कर दिया ऐसे फाइंड करेंगे, ठीक है। ये तो हमने हर n के लिए फॉर्मूला निकाल दिया ना। Only for large n, for very very large n, this approach is e to the minus 1. This approach is e to the minus 1 only for when n tending to infinity. Okay. Small n हो, n is equal to 3 हो, n is equal to 4 हो, तो फिर कैसे निकलेगा? तो फिर इस फॉर्मूले से निकाल देंगे। ओके,
ये फॉर्मूला और शॉर्ट नहीं हो सकता, क्योंकि अगर 50 है तो ये एक एक करके अगर करने बैठेंगे तो बहुत टाइम लग जाएगा।
बड़े n के लिए अप्रोक्सीमेशन ही होगी और वो e to the -1 आंसर आ जाएगा। तो शॉर्ट हो गया ना?
नहीं, अगर 50 है, 50 तो बड़ा n नहीं है।
मैं तो 50 को बड़ा समझता हूँ। इट वुड बी क्लोज टू 0.368 करके देखें आप कैलकुलेटर के ऊपर। सो इट वुड बी क्लोज टू 0.368। ओके, so conditional probability and independence. So I'll start with an example. I'll give you an example. Let's say we toss two coins, and we have seen this example before. Toss two coins. How many points in the sample space? Everyone knows that there are 4 points in the sample space. What is the probability of both heads? Probability of both heads. Answers in the chat window. The sample space is head, 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 tail, tail, head, and tail, tail. 4 sample points. What is the probability of both heads? Everyone says that this is 1/4. Is the probability of both heads. Right. E1 is the event that first coin is head, and E2 is the event that the second coin is head. So the probability of E1, the first coin is head. ये भी हमने निकाली दिया. We have seen this example before. What is the probability of E1? Answers in the chat window. What is the probability of E1? Probability of E1 is the event that first coin is a head. That means we are really talking about head, head or head, tail. So probability of E1 is 2 out of 4, which is equal to 1/2. What is the probability of E2? And E2 is really the event that second coin is a head, which is head, head or tail, head. So this is also 2/4, 1/2. Okay. I'm just going to mention something here and move on from there. Is the probability of E1 and E2. E1 and E2. So this is both heads. E1 and E2 means पहले coin पे भी head है and दूसरे पे भी head. Both coins are showing head. This is equal to 1/4. हमने ये ऊपर calculate किया. See, this is turning out to be equal to probability of E1 multiplied by probability of E2. ये मैंने ऐसे खामखा नहीं लिखा. There is a reason that I have written it. Okay. So in this specific case, we have seen the probability of E1 and E2 together, or the probability of their intersection, is equal to the probability of the individual events के product. Now, this is a condition. This is a condition which tells us that E1 and E2 are independent. This is a necessary condition and sufficient condition for E1 and E2 to be independent. अगर दोनों की intersection की probability उनकी probability की product के equal आ जाती है, then 2 events will be independent. And same for 3 events. Okay. But for 3 events, we have to be a little bit more careful. Okay, दो की जो pair बनेंगे उनकी भी probability इसी तरह से है और 3 के साथ भी यही. So for now, we are talking about just 2 events. The probability of the intersection is equal to the product of the probabilities. E1 and E2 are independent. Let's just take a look. In this question, in this specific example, we can actually observe what is E1 and what is E2. We have defined E1 to be the first coin as head, E2 as second coin as head. These 2 coins are independent. Intuitively, whatever shows up on the first coin should not impact whatever shows up on the second coin. So पहले coin के ऊपर जो भी आया है उसका क्या उसके दूसरे की coin की सेहत पे कोई फर्क नहीं पड़ता. Okay, so the face which is showing on the second coin is intuitively independent of the face which is shown on the first coin, because these are 2 separate coins. Okay, and this relationship here, probability of E1 E2 is equal to probability of E1 multiplied by probability of E2. This This verifies that indeed E1 and E2 are independent. Indeed, E1 and E2 are independent. They do not impact each other because these are on two separate coins. Okay. So we will talk more about that. I'm going to move on to one more example, which will define conditional probability, and then we will relate the conditional probability with independence. Okay. So another example is balls in a box. So we see these kind of examples all the time. Okay. So five red and 3 black balls. Okay. 5 red and 3 black balls. 1, 2, 3 black balls and 1, 2, 3, 4, 5 red balls. 5 red balls. 5 red and 3 black balls. So we draw the balls randomly. Without replacement. Draw 2 balls without replacement. Without replacement means do not put the first ball back into the bin before drawing the second one. Okay. So I'm going to ask this question. Let R1 is the event that first ball is red. B1 is the event that first ball is black. Everyone will agree that R1 is the same as B1 complement and B1 is the same as R1 complement. कि पहली बॉल अगर रेड आ गई तो ब्लैक नहीं होगी, अगर ब्लैक आ गई तो रेड नहीं होगी. So they are complement to each other. R2 is the event that second ball is red and B2 is the event that second ball is black. I'm going to ask some very simple questions. What is the probability of R1? What is the probability of R1? Answers in the chat window. So few people are saying, actually everyone is saying 5 by 8 except for Hamd, who thinks that this is 1 over 5. Why this is 1 over 5? Probability of R1, the first ball that you pick randomly out of these 8 balls, there are 5 red balls out of these 8 total balls. So this should be 5 over 8. So yeah, so everyone has now agreed that this is 5 over 8. This is 5 over 8. Very simple, very simple. What is the probability of R1 complement? R1 complement. So it should be 1 minus 5 over 8, which is 3 by 8, which is, by the way, also the same as probability that first ball is black. First ball is black. Okay. So I'm not going to ask you yet what is the probability of R2. I'm going to ask you a slightly different question. I'm going to ask you this question, that probability both balls are red. Both balls are red. Okay. So this is really the probability of R1 and R2. Probability of R1 and R2. What is this probability? Answers in the chat window. बेशक प्रोडक्ट की शक्ल में लिख दें, बेशक एक आंसर लिख दें. 5 by 8 into 4 by 7. Somebody says that this is 5 by 8 into 4 by 7. ये आपने गेस किया. So lots of people are saying, oh, well, 4 people are saying that this is 5 by 8 into 4 by 7, and this is a correct guess. This is a correct guess. You can reach this answer by counting the sample space, points in the sample space, and the event that R1 and R2 occurs. How many ways R1, R2 can occur? You can count this. So this is the correct answer. I'm going to ask you one more question. This 5 by 8, what is this probability? what is this probability? 5/8. अभी हमने निकाली है ऊपर. It's probability of R1. It's probability of R1. How about this probability? What is this probability? Answers in the chat window. So my question is this probability of R2? Is this probability of R2? Well, now think about it. अभी हमने ऊपर एक इंडिपेंडेंस वाली बात की है. हमने कहा है कि when two events are independent, then the probability of their intersection is equal to the product of individual probabilities. So यहाँ से इसको PR2 कहने से ऐसा लग रहा है मुझे कि we are thinking in our head that probability of R1 and R2 is equal to probability of R1 multiplied by probability of R2, which only happens when R1 and R2 are independent. Which only happens when R1 and R2 are independent. In this particular example, are R1 and R2 independent? क्या वो independent हैं? Is R1 independent of R2? No, because the probability that you get a second red ball is really dependent upon what happened on the first ball. वो तो black भी हो सकती है. वो first ball black भी हो सकती है. So this is not the probability of R2. This is not the probability of R2. If this is not the probability of R2, what is this probability? What is this probability? This probability is R2 given the first ball is R1. First ball is red. This is the probability that second ball is red given that the first ball is red. So this is the probability. The notation for saying that is the probability of R2 given R1 is equal to this 4/7 number. And this is called conditional probability. The condition which is given to you is R1. What that means is it is given to you that R1 has occurred. It is given to you that R1 has occurred. What that means is if we tell you that R1 has occurred, तो आप इस बॉक्स में से जाके एक रेड बॉल को चुप करके निकाल देंगे, because it is guaranteed that the first ball is red. एक रेड बॉल को निकाल देंगे, and then find out the probability of R2 given that condition. एक रेड बॉल को यहाँ से निकाल दें, एक रेड बॉल को यहाँ से निकाल दें, फिर देखें 4 रेड रह गई और 3 ब्लैक रह गई. So the probability of another red is going to be 4/7. 4/7. So this is probability of R2 given that the first ball was red. What would be the probability of R2 given that the first ball was black? Given that the first ball was black. Answers in the chat window. Answers in the chat window. It's going to be 5/7. Why? Because now you are given that first ball was black. So चुप करके एक black ball को वहां से निकाल दें. Now you have to draw the second ball. Second ball, what is the probability that it would be red? Given that the first ball was black. So first ball को black को हमने remove कर दिया. उस situation में now you are left with 5 red and 2 black balls. 5 red and 2 black balls. So that means the probability that you get this second ball as red is 5/7. But given that the first ball was black. Okay. So knowing this, the probability of R1 and R2, ये जो हमने ऊपर ये मालूम किए, so this is really equal to the probability of R1 into the probability of R2 given R1. R2 given R1. This is called the multiplication rule. Okay, and this also leads us to the definition of conditional probability, and that definition is probability of R2 given R1 is equal to probability of R1 R2 divided by probability of R1. या ए बी की शक्ल में लिखना तो हम ऐसे भी लिख सकते हैं, probability of A given B is equal to probability of A and B together divided by probability of B. And similarly, you can also write probability of B given A is equal to probability of A and B together, which is the same as probability of B and A divided by probability of A. So this is the definition of conditional probability. This is your conditional probability. Conditional probability. So conditional probability तो पता चल गया. Conditional probability तो पता चल गई. Now I'm going to ask this question. What is probability of R2? What is probability of R2? Now, this is the probability that the second ball is red. We cannot directly answer this question until we know what happens on the first one. कि पहली वाली बॉल अगर रेड थी तो probability of R2 given R1 कुछ और होगी. अगर पहली वाली जो है वो ब्लैक थी तो probability of R2 given B1 जो है वो कुछ और होगी. So what is actually probability of R2? There are multiple ways that you can reach the second ball as red. Second ball as red. वो कैसे हो सकता है? वो ऐसे हो सकता है कि if you think about it, कि first ball is black, first ball is black, or the first ball is red, or the first ball is red. This is your first ball. What is the probability that the first ball is red? The first ball is red. ये हमने सबने देखी थी, ये ऊपर 5/8 थी. So this probability was 5/8, and this probability was 3/8. But this was only the first ball. First ball कोई सी भी हो सकती है. उसके बाद second ball आपके पास वो भी कोई सी भी हो सकती है. Okay. So you can have the second ball as black, second ball as black, okay, or second ball as black, दोनों पाथवे पे. Or you can also have the second ball as second ball as red, or second ball as red. So this all is second ball, which could be red, which could be black. Red होने के लिए वो दो pathways हैं जो आप follow कर सकते हैं. So if the first ball is red, what is the probability given this, what is the probability that the second ball is also going to be red? Is 4/7. What is the probability second ball is black? Is going to be 3/7. बिल्कुल उसी तरह जैसे इन दोनों का सम जो है वो 1 है, बिल्कुल उसी तरह से इन दोनों का सम भी 1 होगा. If the first ball is black, what is the probability that the second ball is red? Is 5/7, and this is going to be 2/7. And this is the probability that second ball is red given that the first ball was red. This is the probability that second ball is black given that the first ball was red. Yeah. So the probability of R2 that the second ball is red, this can occur in two ways. एक ये हो सकता है आपके पास और एक ये हो सकता है. So इस पाथ की probability और इस पाथ की probability वो हमें पता होना चाहिए. So this would be 5/8 into 4/7. 5/8 into 4/7 plus 3/8 into 5/7. I will explain what each of those terms is. ये चारों terms को बताते हैं. ये वाली जो term है 5/8, this is the probability of R1. This 4/7 is the probability of R2 given R1. Okay. R2 given R1. This is the probability, 3/8 is the probability that the first ball is black. Okay. And this is the probability that the second ball is red given that the first ball is black. So यहाँ पे ये हमारे पास क्या बन गई? So this is probability of R2 given R1 multiplied by probability of R1. So this is probability of R1 and R2. Okay, both balls are red. The first ball is red and the second ball is red. इन दोनों का product अगर जो भी है. और इन दोनों का अगर हमने प्रोडक्ट लिया है, दिस इज द प्रोबेबिलिटी ऑफ B1 R2. B1 R2. That the first ball is black and the second ball is red. Now, I'm going to ask you, why did we add these two guys? Why did we add these two guys? Answers in the chat window. Why did we add these two guys? इन दो चीजों को हमने ऐड क्यों किया? Simple explanation of this. Oh, these are mutually exclusive. So these are mutually exclusive. Why? Because आपके पास या R1 R2 हो सकता है या B1 R2 हो सकता है. ये दोनों simultaneously नहीं हो सकते. ये दोनों simultaneously नहीं हो सकते. So this guy and this guy are mutually exclusive and both lead to the second ball to be red. The second ball to be red. So all of these paths in this tree diagram that I have drawn, all these paths are mutually exclusive. All these paths are mutually exclusive. ये बिल्कुल जो end तक आपको लेके जा रहा है, ये mutually exclusive का end है. Okay. So the probabilities along this path and along this path, I'm just going to add those. Why? Because they are mutually exclusive. What is the probability of this event and this event happening together? This or this happens. If the first event happens, R1, R2 happens, then the second ball is red. If B1, R2 happens, then still the second ball is red. Okay, and that is the probability that we wanted to find out. What is the probability that the second ball is red? So I just add these two probabilities of these two mutually exclusive events. Okay. This division is also called partitions. Partitions or law of total probability. Law of total probability. Yeah, इसको partitions भी बोलते हैं. We will formally define these partitions as well. So Zain, do you have a question? Zainul Abdin?
No, sir.
वो आपने unmute किया था. So I'm just going to mute you. All right. So conditional probability is tied to another concept which is called a reduced sample space. Reduced sample space. What is reduced sample space? Now, the idea is very simple. देखें, reduced sample space क्या है? कि once something is given to you, the conditional probability means something is given to you, and then we ask you the probability of some other event. So probability of A given B, इसमें you are guaranteed that B has occurred. इसका मतलब है कि एक ऐसी outcome आ गई है जो B के अंदर lie करती है, जो B को support करती है. एक ऐसी outcome आ गई है जो B को support करती है. B is given to you. Given B, find the probability of A. ठीक है. Normally when we find the probability of an event, so कैसे हम find करते हैं? So a probability of an event E, recall करें कि probability of event E is number of sample points in E divided by number of points in the sample space. ऐसे ही होता है ना? So now think about it. Okay, if you have the sample space in which you have event E and there is an event F. There is an event E and there is an event F. And then you have these red outcomes which all support F. ये जो red outcomes हैं, ये F को support करते हैं. And then you have these green outcomes which support only E. ये जो थोड़ी सी जो कॉमन में जो रेड है वो और ग्रीन मिलके E को सपोर्ट कर रही है. एंड देन यू हैव maybe brown outcomes जो बाकी हैं. ये बहुत सारी आउटकम्स हैं आपके पास. सो प्रोबेबिलिटी ऑफ E क्या होती है? प्रोबेबिलिटी ऑफ E होती है ये वाला एरिया हमारे पास, नंबर ऑफ पॉइंट्स हियर Number of points here. Samar, you have a question? Right? Okay. Okay. Now, so the general definition of probability is that number of points in E, probability of an event E is the number of points in E divided by number of points in the sample space. If something is given, if F is given, now you know something. अब आपको पता चल गया कि now your world is confined to F. Now you are guaranteed that one of the red outcomes has occurred. Guaranteed that one of the red outcomes has occurred. Kyun? Because F is given. F only occurs when one of the red outcomes occur, because those are the only ones which support F. So इसका मतलब है कि अब now your world is limited to these red guys. Your world is now limited to these red guys. Okay. So the probability of E given F is really now the number of points in E in reduced sample space, And what is the reduced sample space? The reduced sample space is just these red guys. बाकी तो अब अगर कर ही नहीं सकते, ना ग्रीन वाले अगर कर सकते हैं, ना ब्राउन वाले अगर कर सकते हैं. हमें पता है कि ब्राउन वाले और ग्रीन वाले ये आउट ऑफ बाउंड्स हो गए. ओनली एफ के अंदर जो हैं सिर्फ वो वाले इन प्लेस हैं, डिवाइडेड बाय नंबर ऑफ पॉइंट्स in reduced sample space. So what this is number of points in E intersection F divided by number of points in F. Now what I can do is I can divide both of these with the number of points in omega. दोनों को divide कर सकते हैं. It's not unfair. So इसको divide किया number of points in omega और इसको भी divide किया number of points in omega. It's not unfair. कुछ भी नहीं change लेकर आए. But now you can see that in the numerator, what do you have? In the numerator? What is that? We are familiar with that. Number of points in E intersection F divided by number of points in omega. This is the probability of E intersection F. And in the denominator, number of points in F divided by number of points in omega. What is in the denominator? Answers in the chat window. Is the probability of F. So probability of E given F is equal to this. And this is exactly the same. E given F is E and F together divided by probability of F. Okay. This is exactly the same जो हमने यहाँ पे लिख दिए, या यहाँ पे लिख दिए, या यहाँ पे लिख दिए. ये हम सब पहले देख चुके हैं. Okay. So this is again your conditional probability. So I'm going to talk about the reduced sample space a little bit more. एक example से इसको करते हैं. Reduced sample space example. और इसको example हम जो है यहाँ से ऊपर से उठा लेते हैं. You guys for example. This one. Copy and paste. Okay. So toss two dice together. Okay. Let's define some events. Define define an event E that sum of faces is 8. ये इस तरह की एग्जांपल्स हमने बहुत की थी पिछले लेक्चर के अंदर. What is the probability of E? Probability of E. काउंट करें कि कहां पे 8 आ रहा है आपके पास. 6 and 2, 6 and 2, this guy, or 5 and 3, 4 and 4, 3 and 5, and 2 and 6. These, ये जो मैंने सर्कल कर दिए, these are the outcomes. These are the outcomes which lead to the sum of the faces to be equal to 8. So what is the probability of E? Answers in the chat window. Answers in the chat window. Just 5 over 36. 5 over 36. Let's also define F that the first dice is a 3. First dice is a 3. So इसको भी हम draw कर लेते हैं. First dice is a 3. First dice is a 3. So the first roll is a 3 here. This is your event F. This is your event F. What is probability of F? Answers in the chat window. Answers in the chat window. What is the probability of F? What is there? Yeah, it's 6 out of 36. 6 points हैं F के अंदर. F के अंदर 6 points हैं out of 36. So the probability of X is F is 1 over 6. If you are given F, okay, what is the probability of E given F? Probability of E given F. Okay. Now, हम कैलकुलेट कर सकते हैं इसको. कैसे कैलकुलेट कर सकते हैं कि probability of E and F together divided by probability of F. So probability of F हमने पहले मालूम कर लिया है. Probability of E and F together. What is the probability of E and F together? What is the probability of E and F together? The probability of E and F together, देखिए कहाँ पे intersection हो रहा है E और F का. सिर्फ एक ही point है जहाँ पे intersection हो रहा है. And that point is this green guy. That point is this green guy. जिस पे E और F का intersection हो रहा है. So this is 1 out of 36 divided by probability of F, which is 1 out of 6. So ये आपके पास so 1 by 6 1 by 6. लेकिन ये तो हमने वैसे कैलकुलेट कर दिया. ये रिड्यूस सैंपल स्पेस से नहीं कैलकुलेट हुआ. लेट मी ट्राई टू कैलकुलेट द सेम थिंग. Calculate the same with reduced sample space. With reduced sample space. उसको कैलकुलेट करते हैं. So the probability of E given F is equal to number of points in E in reduced sample space divided by number of points in reduced sample space. And reduced sample space is really given F, so number of points in reduced sample space, yeah, number of points in F. Okay, so what is the number of points in E in reduced sample space? So देखें पहले E event कौन सा है? E event वो है ये blue circles वाला. E event जो है वो blue circles वाला है. Okay, I'm going to raise the screen guy for a little bit. So E event is the blue circles guy. Okay, and what is the number of points E in the reduced sample space? And where is your reduced sample space? Your reduced sample space is this yellow guy. Oops. Your reduced sample space is this yellow guy. So the number of points in E in the reduced sample space, the number of points in E, ये किसी ने बिलाल आपने लिखा number of points in E is 1. That is not true. The number of points in E is 5. Is still 5. But the number of points in E in the reduced sample space, number of points in E in the reduced sample space is this one. Okay. And the number of points in the reduced sample space itself is 6. So 1 over 6. So obviously ये same ही answer आना था. गलत different तो आ नहीं सकता. So I'm going to close this example, but before I do that, ये हमने ड्रॉ किया, ऊपर से कॉपी पेस्ट किया, तो एक सवाल इसमें और पूछ लेते हैं, एक डिफाइन करते हैं एक इवेंट. Let's define an event H. Let's define an event H is that first dice shows a 1. First dice shows a 1. So where is H? Where is H? H को हम शो कर देते हैं ये ग्रीन कलर से, मे बी ये ग्रीन कलर से शो कर देते हैं. So H is this color. This is your H. This is your H. Okay. So probability of E given H is again number of points in E in reduced sample space divided by number of points in reduced sample space. अब ये एक डिफरेंट रिड्यूस सैंपल स्पेस है. वो f गिवन जब f गिवन था, तो this yellow one was your reduced sample space. Okay. When h is given, your reduced sample space is this green one. फिर अब आपकी जो reduced sample space है वो ये green वाली हो गई है. Okay. So now what is the number of points in E in the reduced sample space? देखिए कोई overlap ही नहीं है. Blue वाला जो है कोई green के साथ overlap ही नहीं कर रहा. So this is going to be 0. It's going to be 0. Okay, makes sense? Okay. So I'm going to do one more example of law of total probability. So this example is about radar detection. कोई जहाज एयर स्पेस में आ जाए तो उसको एक radar से डिटेक्ट करते हैं. So if an airplane comes here, you have a radar. ये radar जो है ये डिटेक्ट करता है if there is an airplane. ये पता नहीं कैसे बनेगा. So this airplane comes in the range. So this radar ये यहाँ से ये waves फेंकता है, वापस रिसीव करता है and detects के there is an airplane in the range. ये हमारी एयर स्पेस के अंदर घुसा है. There is some guy here. So let's say in an airspace the aircraft is present. कभी-कभी आता है with probability 0.05. बहुत थोड़ी probability है कि वो आएगा. 1 out of 20. Okay. Now, if aircraft is present, ये लग रहा है कि कुछ conditional probability है क्योंकि you are given that the aircraft is present, then radar detects it, registers the presence, मतलब वो उसको डिटेक्ट कर लेता है, registers the presence with probability. ये बड़ी हाई होनी चाहिए. क्यों हाई होनी चाहिए? अगर हाई नहीं होगी तो इसका मतलब है उस रेडार को बंद करके घर भेज दें. अगर एयर स्पेस में एयरक्राफ्ट आ गया है तो रेडार को बड़ी अच्छी प्रोबेबिलिटी के साथ उसको डिटेक्ट करना चाहिए. So that's why this is a high number. Okay. लेकिन कभी-कभी रेडार से गलती हो जाती है. वो बर्ड को देख के भी कह देता है कि ये एयरप्लेन आ गया है, ये यहाँ एयरक्राफ्ट आ गया है. ठीक है. If aircraft not present, then radar may still register with some small probability. एक थोड़ी सी कभी-कभी एरर होती है उससे. Radar may still register with probability 0.1. So the question is find the probability. Number 1, the probability of what we call a false alarm. I will explain what that is. And number 2, the probability of missed detection. ये दोनों ही ऐसी चीजें हैं जो रेडार के अंदर प्रोबेबिलिटी ऑफ फॉल्स अलार्म ये भी बहुत स्मॉल होनी चाहिए, प्रोबेबिलिटी ऑफ मिस डिटेक्शन ये भी बहुत स्मॉल होनी चाहिए। दोनों लग रहा है कि कोई गलत चीजें हैं, दोनों लग रहा है नाम से ही कि गलत चीजें। ओके, सो फॉल्स अलार्म मींस कि एयरक्राफ्ट इज नॉट देयर एंड द रेडार सेज कि एयरक्राफ्ट इज देयर। मे बी उसने किसी बर्ड को देख के कहा है या किस वजह से उसने कह दिया, ठीक है, कोई एरर हो गई है उससे, ये डिटेक्ट करना है, ठीक है। सो दैट्स द प्रोबेबिलिटी ऑफ फॉल्स अलार्म। Probability of misdetection is when the aircraft is present but the radar says कि कुछ भी नहीं है वहां पे, so उसने मिस ही कर दिया, डिटेक्ट ही नहीं किया उसको। So the probability of misdetection is हमें ये दोनों चीजें फाइंड आउट करनी है, ठीक है। So इसको आंसर कैसे करना है? आंसर करते हैं सबसे पहले कि let's say कि A is the event that aircraft is present. Aircraft is present in the airspace, is present, and let's say B is the event that radar registers the presence, radar registers the presence. So 1 और 2 में हमें क्या क्या क्वांटिटी चाहिए in terms of A and B? 1 और 2 में हमें क्या चाहिए? What is the probability of false alarm? What is that probability? Answers in the chat window. Answers in the chat window. 1 में वो क्या पूछ रहे हैं? Probability of false alarm in terms of A and B. In terms of A and B, what is this guy asking? Probability of false alarm. False alarm का मतलब क्या है? False alarm का मतलब ये है कि आपके पास एयरक्राफ्ट नहीं है और उसने false alarm दे दिया, उसने कहा है एयरक्राफ्ट, which means कि उसने register किया है and the aircraft is not present, which means कि this guy is asking probability of B given A complement. B given A complement. Probability of B given A complement. किसी ने वो A complement को S minus A लिखा है, which is fine. और probability of alarm लिखा है, which is B basically. Registers the presence. Alarm नहीं, इसको register कर रहा है वो presence को. So second, what is the probability of misdetection in terms of A and B? What is this quantity? What is this quantity? What is this quantity? Missed detection. What is this quantity in terms of A and B? Answers in the chat window. We are waiting. What is the probability of misdetection? कि aircraft आ गया, radar ने register ही नहीं किया. This is the probability of B complement given A. Aircraft was present. It's given that aircraft was present, but did not register. Radar did not register. So now, again, I'm going to draw the tree diagram here. Okay, aircraft present or aircraft not present. Aircraft not there. ये दो ही पॉसिबिलिटीज हो सकती हैं और फिर उसके बाद वो डिटेक्ट करेगा registers, does not register, and again ये भी हो सकता है कि एयरक्राफ्ट नहीं हो तो तब भी रजिस्टर कर दे, registers and does not register. So I'm going to ask this probability. What is the probability aircraft is present? ये हमें उन्होंने दी हुई है, aircraft is present with probability 0.05. This is 0.05. This 0.05, so this has to be 0.95. What is the probability that you register? What is the probability that if aircraft is present, then the radar registers the presence with probability 0.9. So अगर ये present है और वो register कर ले, so this is with probability 0.9. And what is the probability? ये जो आपको 0.1 दी हुई है, this is the probability if aircraft is not present, then you may still register. Aircraft is not present, then you may still register with probability 0.1. This is the probability of B given A complement. This is probability of B given A complement. What is this probability? This is probability of B given A. B given A. This was our requirement. This was our requirement. ये 1 में जो पूछा गया था B given A complement, ये 1 में पूछा गया था. 2 में क्या पूछा गया था? 2 में ये चीज पूछी गई थी, probability of does not register, which means B complement given A. Given A. यहाँ पे आपका A है, ये A complement है. So probability of B complement given A, what is this probability? What is this probability? B complement given A. This is missed detection. This is missed detection. This is going to be 0.99 ka complement, which is 0.01. 0.01. And this similarly, this guy is going to be 0.9. Okay. Okay. Now, I'm going to ask you this question. I'm going to ask you this question. Probability radar is correct. Radar is correct. कहां पे radar correct है? Aircraft present हो और उसको register कर ले तो radar is correct. Aircraft not there और register ना करे, aircraft is still correct. Aircraft is still correct. So aircraft is correct. 0.05 into 0.99 plus, why? Because these are again mutually exclusive, plus 0.95 into 0.9. 0.95 into 0.9. And this is whatever the answer is. So now I'm going to ask two important questions, and I will let you think about those two important questions. One is, what is the probability? What is the probability that radar registers? वो declare करता है कि aircraft है. What is the probability that radar registers? Which means I'm interested in finding the probability of B. Interested in finding the probability of B. How to find that out? This can be answered again by partitions. By the way, ये जो हमने आंसर किया है, ये भी partition से ही आंसर किया. This is also partitions. By partitions, ये आंसर कर सकते हैं. Probability of B. So I will let you think about it कि probability of B कैसे find out करेंगे. ये register करना है आपने. So एक ये वाला path है और एक ये वाला path है. ये जो दो मैंने red के अंदर कर दिए. Maybe red is not the right. इसको green से कर देते हैं. In fact, एक ये वाला path और एक ये वाला, ये जो दो path हैं इन पे registration कर रहा है और you can compute that probability. The second question is, and we won't get the answer to that today. We won't get the answer to that today. By partitions, ये वाला by partitions. If the radar registers the presence, what is the probability? What is the probability of aircraft being present? Good chance है कि वो होगा. अगर radar जो है वो जनरली अच्छा ही काम कर रहा है. If the radar declares कि भाई मैंने तो aircraft देख लिया, लेकिन हमें पता है वो कभी-कभी गलती भी करता है. Sometimes it makes mistakes. Okay, so if the radar registers the presence and declares that I have seen an aircraft, what is the probability that actually the aircraft was present? What is that probability? This cannot be answered directly, but it can be answered by using this tree diagram. And by using this diagram, this tree diagram, this can be answered by what we call Bayes rule, or Bayes formula, Bayes rule or Bayes formula. We'll talk about that in the next class. Okay. We have a quiz on Monday at 9 p.m. We'll just open it at 9 p.m. Will be available for 25 minutes. So you can attempt that. It would be online on LMS. If there are any questions, feel free to post them all on Piazza, so that other people can also benefit from your queries, and we can avoid the repetitions there. Everything that we have covered, ये announcement के अंदर आया हुआ है, उसको पढ़ लें एक दफा जाके, उसमें और भी important चीजें लिखी हैं. So if you have not read that, just make sure that you go ahead and read that. उसमें syllabus का भी सब लिखा हुआ है. Okay? Everything including today's lecture is included in the is for the quiz, is fair game for the quiz. Okay. I'll focus more on the topics before the conditional probability and independence. So conditional probability independence को हम ज़्यादा focus नहीं करेंगे. Yeah. So it won't be an MCQ. It won't be an MCQ. There might be a question on, which is an MCQ, but overall you will have to solve something. And please keep a pen and paper with you so that you can solve it and just register the answers on LMS. LMS पे हम सिर्फ final answer हमें चाहिए. So I will send out an email about that. Any other question? Here is one.
सर मैं वो पूछना चाह रहा था कि आप ईमेल कर देंगे इसके बारे में, पर वो आपने खुद ही कह दिया था. थैंक यू.
इन क्विज का प्रोसीजर वगैरह तो हमने कर दिया पहले से ईमेल. इन एडिशन टू दैट अगर कोई चीज हुई तो वो मैं उसको ईमेल कर दूंगा. जी अब्दुल्ला.
Sir, I had a question about the hat matching problem.
जी जी.
सर वो जो फॉर्मूला हम निकालते हैं एंड पे रिक्वायर्ड प्रोबेबिलिटी का, उसमें 1 माइनस एक सीरीज आ रही है ना, तो वो जो 1 माइनस के आगे वाला पार्ट है वो e⁻⁻1 है ना?
नहीं, इस 1 को भी मिला के वो e⁻⁻1 है.
अच्छा ठीक है सर.
जी जी. वो अगर आप देख लें, क्योंकि ये e to the x जो है, ये e to the x जो है वो I is equal to 0 से जाता है. तो I को जब 0 डालेंगे ना यहाँ पे, तो ये आपके पास 0 फैक्टोरियल जो है वो 1 होता है. So it's including this guy. It's including this guy. So this would be x power 0 over 0 factorial. वहां से स्टार्ट होगा.
ओके.
ठीक है. Okay, any other question? So as I said, we will focus more on the material which is covered, until the first part of today's lecture. ये हमने conditional probability और independence से पहले जो पढ़ा है उस पे ज्यादा फोकस करेंगे. conditional probability independence से मे भी कोई minor सी कोई चीज पूछ लें, but most focus would be on counting principles and कोई और क्वेश्चन before I close the session? Any other question?
Sir, can we receive these notes?
Which notes?
Sir, these that you are writing on.
वो हमने इसकी बेहतर फॉर्म जो है ना वो एक अपलोड कर दी है, बल्कि शायद अगर अभी नहीं की है तो वो मैं अभी अपलोड कर दूंगा. in a more neater form ये अपलोड कर देंगे.
Okay, thank you.
ठीक है. I will just do that right away. Any other question? Okay, great. And thank you very much. And yeah, all those people who have showed up early in the morning, I know this is too early, but yeah, thank you for showing up. Okay, we'll see you on Monday.